We are students at the GEMS camp, Girls Interested in Engineering, Mathematics, and Science, a nonprofit that provides STEM programming for girls at the Martin Luther King Jr. Community Center located in South Dallas. We are standing right next to the statue of Dr. Martin Luther King Jr. at the center. This statue is so cool. The reason Dr. King has a statue here in Dallas is because the community and city of Dallas wanted to commemorate Dr. King's civic work during the civil rights era in the United States. He led peaceful protests, organized, and led marches for Black Americans to have the right to vote. We can also look at the statue with our math lens. When they were designing the statue, I bet the designers wanted the body to be in proportion and also thought about how tall Dr. King would be represented in the statue. So I was wondering, what is the height of the statue and how does the height compare to Dr. King's actual height?
I did some minor research to find Dr. King's actual height. I found out Dr. King's actual height is 5 feet and 7 inches, or 67 inches.
That's helpful, but how can we find the height of the statue? It's too tall for us to measure.
We can actually find the height of tall objects, buildings, or even statues by using shadows.
Seriously?
Seriously, let's take a look. We're going to use shadows to help us find the height of the statue so we can answer our question. We actually need 2 shadows because we can use ratios and proportions so we can answer our question.
Oh, we learned about those at school, remember? A ratio is a comparison of 2 or more quantities, and a proportion is when we set 2 ratios equal to each other.
You go, Brianna. We can compare your actual height to your shadow's height to find the ratio of your height to your shadow's height. Since those are the 2 lengths we can actually measure. To use shadows to determine the height of large objects, we're going to create a simple formula using measurements that we can find to find measurements we cannot find, like the height of the MLK Jr. statue. First, we need to find your shadow's height, Brianna. Let's find the sunniest spot where we can clearly see your shadow. We will use a tape measure to measure your shadow in inches and record it. I got 90 inches. Then, we'll measure your actual height in inches, which is 61 inches. Next, we'll divide your height by the length of your shadow to get one side of the proportion. That number will be the ratio of your height to your shadow's length. So the ratio is 68 hundredths.
Now, we need to find the length of the statue, right? You know, I think it is important to measure the 2 shadows within 10 minutes of one another because shadows change as time passes.
Great observation, you're exactly right. The shadow's length is one of the measurements we can't find. So let's measure it. The length is 182 inches.
So all we have to do is take our ratios from our measurements and multiply it to the length of the statue. That's 68 hundredths times 182 equals 123 and 76 hundredths inches.
Well, that shows us the height of the entire statue, but notice the statue has a base. We should probably subtract that away since to have an accurate comparison to Dr. King's actual height.
Okay, let's measure that. We got 48 inches. Now we could subtract that away from the statue's total height, 123 and 76 hundredths inches, minus 48 inches. So the height of the specific part of the statue is 75 and 76 hundredths inches. Using ratios from nature like shadows casted by the sun is very useful, and shadows are very useful.
And there you have it, math in action, helping us uncover the height of this incredible statue right here in our community, reminding all who see it the life and the legacy of Dr. Martin Luther King Jr. We hope you learn how shadows are useful to determine the height. Keep exploring, keep learning, and remember, every shadow has a story to tell.
That's a wrap from the GEMS camp at the MLK Jr. Community Center.
Until next time, stay curious.